So, Python 3.14 is officially here, and let me tell you, this is not just another number bump. This release feels like a real turning point for the language, pointing to a future that, honestly, a lot of us have been waiting for. And it brings up the one big question on everyone's mind. Is this the release that finally tackles Python's long-standing reputation for being, well, maybe not the fastest tool in the shed for certain jobs? Let's dive in and see exactly how this version is addressing those performance concerns head-on. Okay, so here's the deal. Python 3.14 is way more than just a simple update. You should think of it as a foundational release. It's introducing some massive shifts in performance, but also in syntax and just general usability that are basically drawing a map of where the language is going. And that direction is all about a faster, more parallel Python. First up, we've got a brand new feature that's been added right into the language's syntax. It's something that looks incredibly familiar at first glance, but it's packing some serious power under the hood. Let's meet template strings, or as you'll see them, T-strings. All right, so you look at this and you're probably thinking, okay, it's just an F string with a T, right? And visually, you're not wrong. But the real magic isn't in how they look, it's in what they return. An F string gives you a simple final string right away. A T-string, though, it gives you something much, much more flexible. And this right here is the secret sauce. A T-string returns what's called a template object. Think of it like a container that keeps the static, raw text parts, like hello, totally separate from the dynamic parts, like the actual value of your name variable. And this separation is what unlocks all its power. So why is that so cool? Well, because you now have access to all the individual pieces, you can loop over them and mess with them. Imagine you want to make sure every name you insert is perfectly capitalized. With a string, you can just iterate through its parts, find the interpolated value, and apply title casing just to that piece. This opens the door for custom input sanitization, complex parsing, or even building completely different things, like an HTML tree, all using this nice, clean syntax. All right, let's move on to the next big thing, which really builds on this theme of a smarter Python. Now, this one is more of a behind-the-scenes change, but trust me, it has a massive impact on both how clean your code is and how fast it runs. We're talking about the deferred evaluation of annotations. Oh man, if you've ever used type hints, you know this pain. The old way, if you wanted to reference a type that hadn't been defined yet, what's called a forward reference, you had to wrap its name in these clunky quotes. It worked, but it always felt like a bit of a hack. Well, say goodbye to that. In Python 3.14, you just write the type name directly. No more quotes, no more weirdness. So what do you get out of this? Well, first, obviously, your code is just cleaner and easier to read. But the second part is a huge performance win. Annotations are now lazily evaluated. That means Python doesn't even bother processing them when a module is first imported. It just waits until they're actually needed. For big applications, this can make your startup time noticeably faster. Okay, deep breath. We've arrived at the main event. This is, without a doubt, the most significant change in Python 3.14. It's a fundamental shift that tackles a limitation that has defined and sometimes frustrated Python developers for decades. We are talking about breaking free of the global interpreter lock, the infamous GIL. So what even is the GIL? The simple explanation is that it's a lock that makes sure only one thread can run Python code at any given moment, even if your computer has a ton of cores. Now, it wasn't created just to be a bottleneck. Back in the day, it made memory management much simpler and helped Python grow really fast. But for modern CPU-heavy tasks, it's been the #1 roadblock to true parallelism for years. And the new solution, now available right in standard Python, is multiple interpreters. This is so cool. It lets you fire up separate, totally isolated Python interpreters, but all inside the same process. Each one gets its very own GIL, which means they can all run code on different CPU cores at the exact same time. You get the memory efficiency of threads, but with the isolation you need for real parallel processing. And this chart says it all. Check it out. Running a heavy calculation on a single thread takes 12 seconds. Now, try to speed it up with a traditional thread pool, and it actually gets slower, 14.4 seconds. That's the GIL overhead, where threads are just fighting each other. But then, look at the interpreter pool, 3.4 seconds. That's a massive game-changing speed-up. It's proof that we're finally seeing true multi-core work in Python. But hold on, because there's more. The multiple interpreter model is one path to parallelism. The other path is even more direct. For the first time, Python 3.14 is offering an officially supported, though still optional for now, free threaded build. This is Python compiled completely without the global interpreter lock. So what happens when we run that same test in a no-GIL world? The results completely flip. Now the traditional thread pool is the fastest option, even beating the interpreter pool. This is what developers have wanted for years, true native multi-threading for CPU-bound work. Now, the huge caveat is that the whole ecosystem of libraries needs time to adapt to this new reality, so it's not something you can just switch on for every project tomorrow. But the future is here. Okay, so beyond those huge performance shakeups, 3.14 also packs in some fantastic quality of life improvements. These are the kinds of things that just make a developer's day-to-day life that much easier. Let's look at a few new tools for your toolkit. If you work with Asyncio, you're going to love this. There's now a built-in command line tool to inspect running async applications. You just find the process ID of your script, pop open another terminal, run python-m asyncio.ps with that ID, and bam! You instantly get a live look at all your running async tasks and what state they're in. This is just incredibly useful for debugging. This is just a nice, clean consolidation. All of Python's different compression libraries, like gzip, bz2, and the rest, are now gathered together under one easy-to-use compression module. Plus, it adds support for Z-standard, which is a fantastic modern algorithm that gives you great compression and speed. It's now a true one-stop shop. And finally, let's talk about some of the smaller changes. The little syntactic tweaks that might not grab the headlines, but really add to the polish and improve the whole developer experience. Here's a perfect example, a small but very welcome syntax change. When you wanted to catch multiple exceptions, you used to have to wrap them in a tuple with parentheses. Well, not anymore. You can now just list them out, separated by commas. It's a minor thing, sure, but it just makes the code that little bit cleaner to read. And there's a whole bunch of other improvements under the hood. Error messages are getting more specific and more helpful. There are new warnings for confusing code you might write in finally blocks, a faster garbage collector, and a new safe way for external debuggers to hook in. All these little things add up to a much more robust coding experience. So let's zoom out and put it all together. What are the big takeaways from Python 3.14? We've got powerful new text processing with T-strings. We have code that's both cleaner and faster because of deferred annotations. And most importantly, we have a clear two-lane highway to true parallelism, with both multiple interpreters and the no-GIL option. And woven through it all is a real focus on just improving the developer's experience. Make no mistake, this is not just another incremental update. The changes in Python 3.14 are deliberate, they're significant, and they are absolutely foundational. They're laying the groundwork for what's coming next, steering the language toward a future where performance and parallelism are core strengths, not afterthoughts. And that really leaves us with one final and very exciting question. For years, the GIL has put certain limits on what Python was considered the right tool for. Now, with those barriers finally starting to come down, with true parallelism right around the corner, what new doors does that open? What will developers build next?